just to add to what Betsy was saying, if you'll note down the bottom where it does talk about next month's, we will not be holding a July meeting just because we'll be too near PERC. But what we will instead do is we will be gathering up quite a bit of information about activities going on at PERC that we think will be interesting to the community, and try to get that shared out to everybody, and hopefully, use the time to focus on what PERC has to offer. So, have at it, Jim.
All right. Okay. Okay, thanks for coming to the systems facing call. Today, we're going to talk about two unique approaches to developing controlled unclassified information compliance systems. Carolyn Ellis from Purdue University and Erik Deumens from the University of Florida will present on their unique approaches to the challenges of supporting controlled unclassified information in their respective academic settings. Let me start by introducing Dr. Erik Deumens is the Director of Research Computing, the Department in Information Technology at the University of Florida. He has been in this position since 2011. Before that, he was a researcher in computational physics and chemistry. He designed software for computational chemistry and taught courses in parallel programming. He has worked as a consultant to install and configure supercomputers throughout his career. Since 2015, he has been working on compliance systems for research on restricted data and has taught workshops on how to set up compliant computing programs at academic institutions. Take it away, Erik.
Yeah, so I want this to be interactive. So if people have questions, the story that I'm going to tell is sort of rich and long, and I cannot cover all of the details. So I'll try to focus on some of the points that everybody can steer me in the right direction. So if you have a particular question, put it in the chat, and I'll try to address that more than other things. So the story at the University of Florida is an interesting one because it has some serendipity in it. 2015 is an important year for controlled unclassified information. The actual executive order is from 2010, but the federal government had a lot of work to do to even make anything close to organize it and make it firm. And what happened is at the University of Florida, we got a big contract in 2015 that required FISMA compliance at the NIST 853 moderate impact level. And it was a big grant, so that the university, the vice president for research said, yes, we want to do this. And I'm willing to invest a significant amount of money to make it happen. And he actually signed the contract, which was a 5-year contract of $40 million total for the 5 years. And he signed it in the beginning of March. And he signed that by 1st of July that same year, 2015, the University of Florida would have a FISMA compliant system to hold the data that was required to be held and manipulated by that contract. Then he called up the CIO and he said, hey, I just signed this contract that will have a FISMA compliant system. Can you guys do it? And the vice president and CIO, my boss, basically said, well, yeah, okay, we'll do it. And that was a 90-day sprint where we basically spent something like 12,000 man hours and woman hours to design a system. And we had, by 1st of July, we had a system stood up that could hold the data. Unfortunately, there were many other things that have to be put in place in order to have a compliance program that we did not have. And one of the problems for the researchers was, which of course is very of interest to this research supporting community, is that the system had nice secure data, but our users that were supposed to work on that contract couldn't do the majority of their tasks. That there was a long list of software that didn't quite work or that didn't work. So it took us another 6 months to actually get to the point where these people could do their work. And then we had to figure out other processes and procedures and modify policies, and all of that happened in the years after that. But we still felt pretty good because by 1st of July, we had this FISMA compliant system. And if you remember, on August 16, the federal government announced a draft federal acquisition rule that basically called out that all data that is marked as controlled unclassified information would, and when that data is handed to a non-federal organization, then that non-federal organization has to put controls in place as documented by NIST 800-171 to properly handle that data. And it referred to the executive order, which basically said whatever is controlled unclassified information will be published by NARA, the National Archive and Record Administration. They have a website. They had it at that time, and they still have it, where it lists all the CUI. So when we saw that, we said, oh, this is very good, because this is going to, put us in a place where we just build a system and we can make it work. The Department of Defense immediately accepted these modifications in its Defense Federal Acquisition Rule Supplement, and that caused a big uproar among all the people who were engaged in any defense contracting. And they said, but we cannot do this overnight. This is impossible. I do have to point out that NIST 800-171 is actually a tailoring or a specification, a fine-tuning of NIST 853 at the moderate level. And the moderate level has 263 controls, and NIST 800-171 has 110 controls. So it's a smaller list, and because we had just implemented the system with the full 263 controls, we thought we were in good shape. And the Department of Defense immediately made it a requirement. Everybody complained, and then the Department of Defense relented and basically said, okay, you don't have to do it from day one. You'll have to do it by December of 2017. The end of December 2017, starting 1st of January 2018, you have to be, for any contract that is export control or anything that the Department of Defense labels as controlled unclassified information, that controlled unclassified information has to be stored and handled and manipulated and transmitted in systems that are operated according to NIST 800-171. So one of the things that we learned, we had built this system, it turned out that the system that we had built was very expensive to maintain. And it was sort of disproportionate for the many small research contracts that come our way and that are currently often Department of Defense contracts. You have a Department of Defense contract, it may have a 1 year or 2 year lifetime. It has a budget of a couple of $100,000, but it takes close to 1,000 hours of manpower of system administrators to configure the virtual machines the way we had set it up. We had built a system that basically used Citrix VDI environment. We had all kinds of firewalls and internal penetration testing and intrusion prevention, and all of that had to be configured so that the different, what they call tenants, the different projects, are cleanly separated from all the other projects, so that you have a certifiable environment that is compliant with all these controls. That's the big difficulty that we overcame, but then we found out that it was just impossible for these many contracts that the DoD was throwing our way. And we initially had about 30, now we have more like 60 or 70, but initially it was 30 per year. And we just couldn't afford. And the vice president for research said, well, the original system you built is too expensive to operate. You have to come up with a cheaper one. So then we started to build one that is, the original architecture was inspired by essentially enterprise architecture. You basically say a group needs some computing resource. You do an analysis of what data they have. Do they have a database server, file server? They need a server for applications with virtual desktop infrastructure type. And then we just configure it and build it together and then operate it. And then when a new project comes on, you start over and you build another one on the same platform of hardware and storage servers. And you create storage area network isolated LUNs, and you dedicate them to a different system, and you have certain virtual machines that you dedicate to the project. And you put networks and ACLs in place to control all of that. So then we started with something that would scale a little better by starting from a high performance computing environment. We basically bought a big cluster with some fast parallel file system. And then we created a software layer that would do this isolation automatically, and it would be configured by basically a GUI, by a graphical user interface where people could sort of select the features they want. And then you have a number of virtual machines that are allocated to a particular group, and you put controls in place so that people can not share data. But we also started a new approach to this, and that's something we did in collaboration with a computer science professor at the Department of Computer Science and Engineering at the University of Florida, Aline Dobra. And he was a real sort of expert in mathematics and in encryption, and he came up with an idea of building something that would be zero trust. At the time, the terminology of zero trust was already existed, but it wasn't in everybody's mind. Now, 6 years later, in 2001, the latest executive order from our president to secure the nation's security basically calls out that zero trust is important. And if you go to many of the seminars and webinars that people are giving about the new version of the CUI environment, which is called CMMC, I'll get to that in a minute, there you see that zero trust all of a sudden is what everybody believes is necessary. What people did in the beginning was to try and just put controls in place. You take your standard computers and you put a firewall around it, or a network ACL, or a permission, and you encrypt data. But the way typical encryption would work is you would take your data, and then you would use a secure connection, SSL or SFTP, and the application would encrypt the data, send it over the wire, and on the other end, the SFTP server or the SSL server would decrypt it and then make it available, and then you would store it to disk. And then if your disk is encrypted, then the disk would be encrypted, the data would be encrypted again. But there is that window that goes from one stage to another. When it's transformed, it gets decrypted by one application, and then it's for a short time or for a long time, depending on the kind of work you're doing, it is unencrypted, and then you encrypt it again. When you go into a zero trust environment, you put extra stuff in place where if you're going to talk to some other server at a port, you're going to have an extra protocol in place to ensure that the port that you're talking to is really the port that you think it is. And you do that with public-private key. You set up a challenge. You say, well, I know your public key is this, and I want you to decrypt, and I encrypt or encode my challenge with your public key. And then I know if you're the right entity that has the private key that belongs to that, matches that public key, then you are the only entity that could get the word out and prove to me that you really are who you say you are, that you are the entity that's associated with that public key. And that then gets propagated throughout the architecture. So we built this system based on zero trust because of the predilection of our computer science professor. But now it turns out in retrospect that that was a very good thing. So now we have a system that we then stood up and we had it certified by by a third-party assessment organization. And they basically went through all the controls, and they told us, well, these things are good. You have to have a plan of action and milestones. That's another thing, terminology from this whole compliance program that one has to get used to. And that is, you basically failed not all of the controls, but some of them. And then you have to say what you're going to do to fix that. So that basically in 2017 got started with the whole controlled unclassified information. And then the Department of Defense has done some research since then, and they found out that actually academic institutions are among the institutions who are the most honest in their statement and assessment of compliance. When they say, yes, I have an environment that is NIST 800-171 compliant, then about 80% of them are actually correct. Whereas many of the defense contractors in the business world, the compliance is much less. It's like 50% or less. So the Department of Defense said, well, this whole mechanism of requiring people by the contractual agreement of the Defense Federal Acquisition Rule Supplement is not good enough. We have to make something more strict, and there has to be an external auditor. We cannot rely on people self-assessing that they are, because apparently they're not doing what they say they do. And in the meantime, there's a lot of proof and statistics that systems get hacked and that intellectual property gets stolen and all kinds of stuff shows up in places where it shouldn't show up. Like one of the biggest examples is the United States has been developing the F-35 fighter, and then in recent years, all of a sudden, there is a Chinese fighter, I've forgotten its name, that looks really very, very close to the F-35. It's almost identical. And what happened is the plans for the F-35 were stolen, and the Chinese built one exactly like it. So the Department of Defense clearly is not happy about that. And so that's why they created a new program, which is called the CMMC, Cybersecurity Maturity Model Certification. And the last word is very crucial in the sense that now they no longer will accept your own assessment that you say, yep, I put all these controls in place, that's what I'll do. And they essentially will put a requirement in the contract that you have to contact a company, and that company will then have to come and assess your system and write a letter that says, yes, we reviewed all the controls of CMMC that this university or company has put in place, and we found that they are compliant. And then that document is necessary as part of your contract negotiation so that you can move forward. And this was developed over the last 2 years. And now there is a plan being talked about that it will be rolled out. Currently, the timeline is still quite long because it could be that some organizations, including academic organizations, that may not be required to be compliant until somewhere in 2025. It's not quite clear yet, but it will be clarified over the next couple of years. Some companies will be required as of this October to be compliant for their next contract, whereas other contracts, especially in academic environments, may not be required to be compliant that quickly. That's sort of an overview of the world and what the University of Florida has done to do this. Right now, we have put in some improvements and new features in our environment, and we are just starting this week a new engagement with a third-party assessment for the next 6 weeks to review our system again and renew it, because actually CMMC requires that you get a certification every 3 years. And so ours was done in 2017, actually 2018. And so it expires about this year, 2021, and we're going to get a new one now, but we wanted to get a new one anyway since we made some changes to our system. So that's my brief story. If anybody has any questions, please ask.
Thanks, Erik. There looks like there's a couple questions here. Is your environment so sophisticated that the end users have a hard time using it?
Well, in order to be compliant and add security, it's more complicated than your standard use of an HPC environment, but it's not that much more complicated. So the initial steps in order to set up your initial connection, they're a little bit harder because there's an extra encryption key. You have to use your University of Florida credentials, which have two-factor authentication. Then you have to use a strong password that we enforce to decrypt a big 2048-bit key that is used for all communication between your endpoint and the server, and to encrypt all your data and to identify yourself for sharing data with other people within the virtual environment. But then once you've set up an RDP session, then you basically have a Windows desktop or a Linux desktop on your workstation, and you just do your normal stuff. So in that sense, it is very similar once you work. There is an extra restriction, though, that you have to be a little bit careful in your planning. When people, we have a full like Python environment inside a Linux virtual machine for science. So we have multiple versions of virtual machines that people can do their work in. But once you're inside these virtual machines, you have no connection to the outside world. You cannot do any email, you cannot FTP anything in or anything out. If you want to transfer some data in, you have to follow a special protocol. If you want to transfer some data out, there's a special protocol that may involve, if you're a student, it may involve making a request to your PI, who is the data manager and responsible, to say, yes, this data could be taken out of the system. So that also means that if you want to get to the latest Python module, you cannot just say, hey, yum update or something. You need to do that. It's a little bit more complicated. And the way we manage that is the virtual machines get managed on the outside. You update the software, and then they get inserted by system administrators in the environment for use. So you have to be a little bit more careful about it, and that's just part of being compliant. Everything has to be much more scrutinized.
Gotcha. You also answered the next question too with that. Can you share who you had to fulfill your CMMC certification?
So currently we did, it's Sarah Brin. It's a company called Sarah Brin. We picked that particular company specifically because they had experience of working with an academic environment. And that is important because if you go with in principle, any auditor could do this. But if these auditors are used to working with banks, or if they're used to working with healthcare organizations, they don't really understand the massive flexibility and sort of diversity that an academic computing environment needs to be able to support, right? They would want you to list and freeze all the software that you have, which means that you can't do any software development inside your restricted environment, which for many of the contracts with the DoD is part of the job. The reason they want universities engaged in this research is because they want some software to be developed. And then if your environment requires that all the software is frozen at all the time, then you cannot debug anything. So that's why we picked a company that had some experience with working with an academic environment.
Great, thanks for that. And finally, can you give an estimate of how many FTEs are dedicated to this?
Well, we have two FTEs that are fully dedicated, and but then they do work with some other people. And then we also have a couple of developers that are, so what we've done is we developed this software, and now we have a small startup company that actually makes it available to others to buy. And so there are some developers that are paid by that company that we work with very closely.
Great, thanks a lot. Let me introduce Carolyn Ellis. Carolyn is a program manager at Purdue University focused on strengthening regulated research program. Over the last several years, she has grown Purdue's program from a single project to a thriving ecosystem, handling various regulations such as HIPAA and NIST 800-171. Carolyn is passionate about growing the research security community through engagements with other institutions. Carolyn, take it away.
Sure, thank you. Put this cute little diagram of you are here. This is where we're beginning. We're starting with my environment that I mostly manage, or am the program manager of, is the elevated security environment that we run. So actually, I was kind of laughing while we said that we were two different approaches. It sounds like we also started in a very similar path. And at the same time, Purdue had been in the ITAR industry with a small cluster for quite some time. And then, just like Erik said, in 2015, here comes a contract that we could not get that clause removed from. We were then in the place where we needed to meet the upcoming 800-171 rules without really having anyone to look at and recognize that here's some best practices. There was pretty much a very blank landscape at that moment. So we decided to look to the cloud. At that point, AWS Gov Cloud was able to handle the quick turnaround that we needed we didn't have the physical space for it that would be separated with US persons only. We couldn't confirm some of those items that were so critical right at that moment. And that was okay. So we invented READ, the research environment for encumbered data. And we were pretty happy to get an AWS Gov Cloud, but I will say when we arrived there, it wasn't the more robust landscape that it is today. There were no templates of here's how to throw security controls around things. There was no orchestration. The reporting became rather one-off within the space. So we invented a lot of tools and processes around this, and essentially it worked. Similar to Erik's, this environment was developed by two architects, two technical architects, and one security compliance analyst. You will notice that researchers were missing from this equation, which also means it was just as challenging as Erik's to use, probably in the beginning. We created this like two-person lockbox system where we both press the key at the same time to allow data out of the system. We had all of these controls covered in the nines. Turns out researchers didn't love this. Not surprised at all, but they also then later confessed to ways they had found, we can figure out the ways around some of these massive controls you've put in. And we're like, oh, good to know. Thanks for admitting to that. We were also using a separate AD. It was standalone from their university accounts. All of this created We spent most of our time dealing with licensing. We spent a lot of our time dealing with account resets or password resets. Generally, our problems were at a very frustrating level. We also recognize, like, one of the questions asks about Windows versus HPC. Our very first environment required the HPC style environment, and we built it in the cloud with that logic that everyone's going to want this amazing flexibility. Turns out every project after our very first one, they really just wanted the computer that they're running in their lab to be in a compliant environment. And most of them were just the Windows machines, possibly needing PowerPoint, some of those items. So we've gladly matured from that moment, but that first project was insanely expensive to run in the cloud in 2016, 2017. That project running the HPC batch programs they were running at a $4,500 bill of monthly Amazon spend. When you look at it now, that's what a cluster node in our open system would cost for 6 years of use. Then we moved toward that summer, recognizing that the frustrations were boiling under the surface with the researchers, that we had locked this down like Fort Knox. And we brought them to the table, as well as many of the players involved from the technical standpoint too. And we were looking at it from, how can we find some middle ground? And actually what we also realized in this process was the middle ground was, we were heavy-handed in our initial assessment of many of the controls. And when we went back and asked for things like an exception or how do we write this up, that this is okay, we almost got laughed out of the room. We were a little more conservative than what the controls had intended, apparently. That helped us move toward maybe this, the Gov Cloud was not the right answer for it. And that was sort of where we came up with the logic of reusing a fun word. So now it's Read Plus. We have modified it to an ecosystem instead of an environment. But this will also include some of the biomedical data that we'll be handling. This includes some of the connections between these places. And it's not just this small location sitting out in the cloud, well, not getting as much use as it needs. I show this one simply because this is one of the most common questions after we say that we destroyed pretty much all of our first environment that we built. And we also shared our knowledge with a whole lot of people of, yeah, this is what we did in AWS Gov Cloud, check it out. So I share this from, I'm not saying AWS Gov Cloud is not the right answer for you guys. It just evolved to not the right answer for us. And we were spending a whole lot of money having it just vanish for essentially what our day jobs were of supporting HPC systems. We were also trying to recreate a whole lot of our experience and our processes in this one-off system. So if your environment already supports that, this is a great fit to it. It did not work in ours. As you can see, yeah, inflexible, and the researchers were not the biggest fans of this environment. Just a brief one. Since we moved back on campus and we took over some of the physical control, or all of them, obviously. We took the physical controls on, as well as we were ready to handle this on-prem. We have been able to add new functionality and make it much easier for the researchers who use our clusters on a daily basis to get into this space and start using a more controlled environment. brief overview. This is what the environment looks like at a very high level. Standard cluster. It's got some controls moving into it. People have returned to using their Purdue central authentication account. So our current cluster, it's very similar to much of the items we do regularly, which has cut down tremendously the amount of support time and hand-holding that the AWS system has required. So we do have a virtual machines for the Windows environments. We recognize that we could offer every form of alternative to open office. We could offer all these alternatives, and yet people still were desperately clinging on to, they wanted Microsoft PowerPoint and must have it. So, alrighty. There's also the likelihood that we'll run into some Windows specific software that will be required in that space. But generally people are using our thin link client to connect to the software packages they need, and they're running these items very similar to they would run on our normal fundamental clusters. The one that is an interesting and steep learning curve for everyone is the no access to email or unrestricted web browsing. And that one gets every single one of them of, what do you mean you're shutting off the internet in this environment? Essentially shutting it off. Obviously we have certain sites opened up with firewalls or those protections, but generally there's nothing. What we spent a lot of time then, once we got this environment up and running, was fixing the background processes, because we recognize that, yeah, actually this screen, we've gotten a lot of use out of this screen. This is in 2017, when a PI would start trying to do regulated research, they were confronted with a choose your own adventure of IT word soup. There's various organizations all doing very similar services, and how does one navigate this space? We were finding that contracts just to share data between universities were taking 8 months to figure out a solution, and the solution was just as eloquent as burning it to a CD-ROM and mailing it. So still a work in progress at that moment. One of the major outputs of that grant was pretty much a directive map of you are here for that researcher. Here is who will be working with you. And we've also modified many of the websites to start adding information and the help documentation that goes right around what's happening at this time in your space. So what goes into the draft TCP? What do you need to know? Do you need to know your endpoints? Do you need to know what research you're working with yet? So we'll help you out through this whole process. Created standard language. I think if you guys are struggling with some of these process level items, setting up a dictionary and standard language is going to be key. We have governance chart. You're welcome to screen grab that or steal it from what we have later. Pretty useful. And here was my closing one of, so this has been a journey the entire time. We've never arrived at a destination, and I'm not sure there ever is going to be one. But CMMC, it has boiled up the same as many of you are facing, that what level are we going to, who's involved, where do where these signatures have to land to, and what gaps do you have to address in the meantime. We're also recognizing that our training program within this regulated space is the white glove of the white glove service. So we don't quite have it under control on how to make this broader to lower the barrier to entry. And probably the one that we're currently talking about the most is researchers, while they love how easy it is to get straight into this controlled cluster, they're also questioning, why is it not do everything my normal computer or my cell phone can do? Let's do video conferencing. Let's do Google style collaboration. Hey, I'd like the internet back. And that one is certainly going to be chipping away at both sides. While we can probably add to what services we include in this environment, we also come with the limitations of you are dealing with very specific and controlled information. The entire purpose around it is export control. So, suppose we can move on to the questions before we have three more slides, but that's on a slightly different topic.
Sure. So we've got a couple questions. Actually, could you answer the FTE personnel estimate dedicated to this?
Is greatly reduced now that we are on-prem. So I would say we are using, let's go with 4 or 5 fractions of people. So we're no longer at we need maybe 6 people to support this in various roles. I think we've reduced that to, let's say about an FTE total.
Okay, and that's compared to when you were doing it in AWS.
Yeah, that one was significantly more people involved with hand-holding roles within that.
And somebody asked, do you run a separate ITAR? You run separate ITAR export control environments separate from this environment?
We do not anymore. They've all merged into this cluster, and while that is more controls than some environments need at the moment, that's at least where we're able to point them to as we look on the other side of the house of how to slightly elevate the security bar over time.
Great. And then Jill had a question about how do you handle situations where you have computer controlled motor or special system, Internet of Things devices, sensors, instruments. Does this environment work okay? Does that provide an ecosystem for those type of research?
We've recently added a jump host to start bringing in some of the data, and I think we're starting to learn and process. I mean, that you have your shared devices like microscopes. You have many of these devices generating the data that needs to be worked with within the system. So we are starting to work down that path, but yes, a jump host for now.
Great, great. Why don't you show your next 3 slides, and then we'll come back and try to capture the rest of the questions.
Okay. Erik and I are both the speakers at this stage, so we're excited to announce that we just were approved for a proposal we submitted to form a regulated research community of practice. And Erik, do you want to?
Yeah, so one of the things that we have learned we are sort of pioneers, and there are some other pioneers at the San Diego and Indiana University. Anurag Shankar comes to mind, who has been doing this since 2010. But there are lots of people who will now be facing this CMMC thing, and it's hard and expensive to learn the hard way. So we feel that there are two good reasons to create a community. One is so that if somebody wants to get started, they can find some other people who have done it and can say what to try and what not to try. Now the academic environment, we all know, is highly variable, and each university has its own political climate and what is feasible and what's not feasible. But there are many paths that have already been tried, and you don't have to go and try them all yourself. There are other people who have gone before you that you can ask questions, and so we want to create this community where we share what we have learned, videos for training materials, documents, and plans for how you do things. And then secondly, we now have this Department of Defense and other federal organizations that are really feeling the pressure of this cyber war that we're in. I mean, every day we almost get a news item that some new hospital or some new university has been hacked with ransomware, and so more and more agencies and all other organizations that your institution may contract with are going to require proof that you are protecting yourself from these possible attacks. And that's where we want to create a community so that we can be, as a community, talking to the Department of Defense and these other organizations with a single voice and say, hey, don't make the rules and the controls so strong and stringent that we cannot do the mission of what a university is supposed to do. So those are sort of two reasons for working as a community, and that's what we propose to do in that NSF-funded project.
I'll give a little overview of what that landscape of, when we say monthly meetings, the workshops are still to be determined, but we're recognizing that it would be great to have some rotating focus topics. And so, for example, wouldn't it be great to learn from your peers who have been there, done that? Let's do something very similar to today's discussion, where you have two institutions who have paved the way for many others, and let's hear what they've been going through. Looking down the road, we'd also like to hear some of the emerging institutions, because there are R2s who absolutely would love to be collaborators in any of these spaces, but that is a very big challenge at the moment to smaller institutions.
And we also want to engage this community and other communities. Like, this community is very important because you are the ones who face the researchers. But then there are other communities, namely the people who analyze and sign the contract. So the grant and contract administrators. So we want to reach out to all these organizations and sort of get them, because everybody is going to be affected in some way, and it's not something that can be handled by one group. And what we're trying to do is build that cross community, special community focused on this, and touching to all these other organizations, administrators, educause, training organizations, security professionals. You see the list here.
So I suppose our ask from this community is, if there's groups that we're missing, if there's groups that are meeting on very similar topics or producing shared items amongst themselves, we would love to know about them. We've just completed 6 workshop series, 6 regulated shops that well, we have a few people on the call who are the pillar leads, and this is going to be an amazing input into this community, as this those workshops pulled together many of the challenges that we're experiencing as a nation, not as just each of our institutions.
Well, great, Carolyn and Erik, this is exciting news, and wish you all the best luck, and we'll certainly follow up with you guys. Couple more questions, and I think this one was for Erik. Would you be able to give an estimate of the cost to get CMMC certified, or is that proprietary?
No, it's what we have found is that the prices vary some, but we have been able to get a current for the FISMA 853 moderate and CUI 171, which is very close to CMMC, but not exactly the same. We got something around $50,000 for one assessment, which then takes of 6 weeks of intense work, plus a couple more, like another month of sort of paperwork and whatever. So it's typically somewhere between 2 and 3 months engagement.
Okay, and so in addition to the firm that certifies you, are you hiring consultants to help you, or are you using locally grown expertise?
No, we actually, this is part of this community building within the university that you have to do. We partner very strongly with the Office of Internal Audit at the university, because they have auditors and they sort of think and know how to help us. And we work with our security office. And so we don't have an extra consultant. And actually one of the things that we like to do with this whole grant is to create a community where we, the community, can act as consultants and advisors and mentors for others.
Okay, and briefly, could you describe what an assessment is? You said it takes about 6 weeks, paperwork and everything. Could you briefly describe what an assessment?
The process is that you first have to create a system security plan. So that's something that you have to write before the assessment begins even. And that's where you document how you meet every control. And then what the assessor will say, you have to present me your system security plan. And then you have to present evidence. So if you, in your system security plan, you say, before anybody gets an account created, they will need to take this training, and then we record that they actually have taken the training. And then we validate their account. Then the assessor, the assessment company, their people will ask you, okay, that's what you say you're doing. Give me a log or maybe the ticket and all the items in that ticket of how you created a couple of accounts. And then if you say, we review weekly these logs and we do monthly a security scan, vulnerability scan, well, then they'll say, well, give us a couple of these vulnerability scans. And then you say, we have a policy at the University of Florida that says you have to do this and this. And then you have to give the link of where is that policy published. So that's the kind of evidence you have to present to these people, and they will go through it.
Great, that's really helpful. And I want to be conscious of our time here. We've gone over by a little bit. Just a reminder that there'll be no July call because we're getting too close to PERC. But any final comments, Carolyn or Erik?
I just want to thank this group for hosting us, and because we consider you as a partner in this proposal. Actually, you're explicitly called out as a partner.
Great. Well, thank you very much. And we'll probably invite you back like less than a year from now to see how it's going, check in, and see how we can be better involved in this as your plan evolves.
We'll be at PERC, so maybe we'll have a chance to run into each other. We're making a presentation at PERC as well, as part of the Trusted CI. Trusted CI is also one of our partners. So
great. Well, thank you very much, Carolyn and Erik. Appreciate it.
Have a great day.
Take care, everyone.